Hello and welcome to this video. In this video, I'm going to describe how to conduct descriptive statistics for PIAAC. This content is created by myself, Matthew Courtney, and I'm an assistant professor at the Graduate School of Education, Nazarbayev University in Kazakhstan. My colleague, Mr. Kaidar Nurumov, is a PhD candidate at the Michigan Program in Survey and Data Science in the United States. And a big thank you to him for contributing to this content. So let's start with a rationale for this script. Now, I'm not going to read this out, but I think it's a good idea if you take your time to read this script carefully and any of the references available. All right, let's move now to the steps that I'm going to take you through today. In the first phase, there are 7 steps, and this is just relating to data management in the R software. In the final steps, there are 6, well, in the final phase, there are 6 steps. There are 6 steps for plausible values and 6 steps for non-plausible values. So as we know, PIAAC data includes plausible values and non-plausible values, and the algorithms that we use are slightly different for these 2 different outcomes, or 2 different variables. Briefly, we're going to use the R software or RStudio interface, and I'm going to describe first how to obtain the data of interest, set the working directory, clear the global environment, install and load the R package management software, and then install and load all packages for the analysis, read in the data, which is in SPSS SAV format, and finally, step 7, explore the data types of all the variables of interest in that SPSS data. Thereafter, depending on whether your variables of interest are plausible values or non-plausible values, I'll take you through the different steps necessary to obtain the mean, the standard error of the mean, and the standard deviation for those variables. Let's now move to the RStudio environment. Now, of course, you should have already installed R, the R software program, and after successfully installing that, you should have then been able to install the RStudio IDE. Now, this script here is available in the description part of this video. So let's start with the very basics. When using R, if there's a hash at the start of a line, it means that the entire line runs no code. It's just annotation, it's just words. Where there is no hash, we are running specialized functions on data. So this script is heavily annotated in order to support you for your analysis of PIAAC data. So what are we doing today? We're using the public use file to estimate adult literacy with plausible values. We're also using the public use file to estimate adult earning power, which is a non-plausible value. We're simply describing this data in terms of mean, standard error of the mean, and standard deviation. As I explained, there's a rationale for this script with some extra background reading. Feel free to engage with that. So let's start with step 1 of phase 1. Okay, we can obtain the data or the code book for the PIAAC data from this website here. We can also gain or obtain the PUF data, that's a public use file data, from this website here. In this case, we are using Kazakhstan as a country example. So the first step that you need to do is on your desktop, create a folder, and you can call it what you like. For me, I've called it PIAAC. Inside that folder, you need to put in the public use file of choice. For us, we choose Kazakhstan, but you might choose another country. And you can also put the codebook in that folder as well. Once you've done that, you need to set the working directory for the folder that the PIAAC data is saved. This means that we're creating a link between the data in the folder and the RStudio environment here. And in a Mac, you use // like this. We use the set working directory function and the address. In a PC, you use backslashes between your for your addresses. As an alternative, you can use session, set working directory, choose directory, and select the folder on your desktop. Once you've done that, fantastic. Let's now move to clearing the global environment. This means that we're cleaning up all the data and all the information that might happen to be here already. So we run this code here. Great. Let's move on to installing and loading the package management software. So this is a package called Pacman, and it's a very useful package. Excuse me, and we can run this code to install the package if we need it. Next, we use the Pacman package and the pload function to install and load, if necessary, those 4 packages for our analysis. You can see what they're used for here. Great, so we're up to step 6. Let's now look at the directory. What's inside our folder? We've made a link. Fantastic. And we can see that we have a code book. Great. This is going to be useful for us. And we also have our data set of interest. In this case, we're using the Kazakhstan data set. So let's read in the Kazakhstan data set with this foreign package and the read SPSS function, thanks to Hadley Wickham. This will take a few minutes depending on the size of that data. We can look at the dimensions of that data. With the basic functions, we can see that it is 6,050 rows and 1,328 columns. Now, there are many columns in that data frame here. However, we're interested in the plausible values. There are 10 plausible values for adult literacy, and we need to use all of these in order to generate unbiased estimates of the mean, reading literacy, standard error of that mean, and standard deviation. So let's first explore the data. We can see that the plausible values, based on the test results, range between 85.4 and 384.5. We can check the structure of the data as well. Okay, it's a number, that's what we need. We can also use the psych package's describe function to look at the data in more detail. We can see the skewness and kurtosis. It's quite normally distributed, as this number is not above an absolute number of 2. Remember, we're also interested in earning power. So let's have a look at earning power. We can provide a summary. All right, so there could be a problem here. This gives us a whole lot of results. Let's look at the structure of earning power. In this case, the data structure is a factor. This is like halfway between a number and a string or a character. What we need, though, is a numeric. We don't want a factor, we want a numeric variable here. So we need to coerce that variable into a numeric variable, and we overwrite it using this series of code. Now we should be able to describe the data more efficiently because it's a number. Again, there's very little skewness, which is fantastic. We have a mean of 297 and a standard deviation of 139. Our minimum is 1, our maximum is 592. So this is earning power for adults in the country. Now remember, the PIAAC research design involves a two-stage cluster sampling. So we need to account for this, and this is done by applying a final sample weight in addition to final replicate weights. So let's just explore these data here, these weights. Okay, these are numeric, it seems. Let's check about the structure. It is a number, and it's a numeric vector running 1 to 6,050. Let's describe that variable just to explore it. Okay, no problem. Again, the jackknife replicate weights. We can see a summary, looks fine. Let's look at the description. That's also fine. So we have a mean of 1,919 and a standard deviation of 1,096. So these are the replicate weights. We can check the structure of the data. No problem, it's a number. Everything is looking good. So we've finished the first phase, and the 7 steps of the first phase is done. Our data is read in to RStudio, and we've explored our variables of interest for our study. All right, so let's go to the next step, which is the series of actions to the left, which is working out the mean, standard error of the mean, and the standard deviation for plausible values, which is actually reading literacy for adults in Kazakhstan. So we're going to select those variables. We can see here we've got plausible values 1 to 10 for literacy. We've got that final sample weight, and we've got our 80 replicate weights. We use a colon to represent everything between, inclusive. So we run that code and we generate a data frame. Fantastic, we've got all the variables. We can look at the column names of that data frame. We can see the 10 plausible values here, the final sample weight, and the 80 replicate weights, all of which are necessary to do the descriptive statistics comprehensively. Let's now move to step 2. We're going to use complete cases for descriptive statistics. You might have your own way to impute those missing values, but it's not such a big deal. Let me just return to the descriptive statistics for the plausible values. When we do a summary, we note that there are 6 NAs, meaning 6 values are missing for 6 people. But for this analysis, we are simply using complete cases. So we run this code. This is the data frame here. This pertains to rows and produces a logical vector, which ensures that we keep everything we need, which is all the complete cases for that data frame. Let's run that. Let's check out the dimensions. Okay, we're a little bit shorter now, 6,044. So we've removed those 6 people that had missing data for their reading literacy. We can check the column names, everything's fine. So the data frame itself includes the plausible values, 10 of them, the sample weight, 1 of them, and the 80 replicate weights. Let's move now to step 3. In this case, we're creating functions to undertake our descriptive statistics. These are specialized functions that integrate the plausible values, the final sample weight, and the replicate weight. I'm going to simply highlight those functions from line 106, it's fine. Now what I can do is save those functions in the global environment. Fantastic. For the next step, I'm going to specify the position of the plausible values and the specific weights in that data frame. We know that the plausible values are PV-lit 1 to PV-lit 10. And the position in that data frame, that focal data frame, is positions or columns 1 to 10. Let's look at the final sample weight and generate its position. Let's check. Its position is column 11. Let's also do the 80 jackknife replicate weights. We note that the position is columns 12 to 91. So with this defined, we can now run the actual functions with the relevant data. Let's do that now in step 5. Fantastic. For the final step, we can print the final results. Let's print the mean and standard error of the mean to 2 decimal places. Okay, we can see that the mean and standard error of the mean are reported here. The mean ability for adult literacy in Kazakhstan is 249.13, with a standard error of the mean of 1.06. So we could report this as 249.13 plus minus 1.06 times 2, because we always use 2 standard errors, above and below the mean. Let's also look at the standard deviation. We can also use the rounded result. The standard deviation is 39.21. There's also a standard error here included, but you don't need to report that. It's not common. So we have now completed the descriptive statistics for the plausible values for the PIAAC data for Kazakhstan. Let's now look at the estimating adult earning power. These are non-plausible values. So in this case, we're going down this right-hand channel or way, and we're carrying out the same steps with slightly different algorithms. So let's begin by only selecting the variables of interest into our focal data frame. So we're going to overwrite this data frame here. Highlight, run, and it changes. 82 variables now, and a total 6,050 observations, or all of them. We can check the column names of the focal data frame. Great, we have earning power in our first position, final sample weight here in our second position, and the 80 replicate weights here as well. We can also check the dimensions. We have 6,050 rows, participants, and 82 columns. Let's only take complete cases in this case. We get a major reduction here, but that's fine. We reduce to 2,708 cases and, of course, the same 82 variables. Here I've provided a table of the variables and the number of columns. Let's move to step 3. Similarly, we can highlight the functions specific to non-plausible values. Okay, we can run that and generate the functions. And we can see here no PV for mean and no PV for standard deviation. Again, we should specify the positions. So the non-PV position is the column that doesn't include SPF weight. We can run that. So the non-PV position is actually 1 in this case. Again, this is for the final sample weight. The position is 2. And here, the position for the jackknife replicate weights, the 80 of them, we run, we check. The position is columns 3 to 82. You can also just do this manually if you like. For example, non-PV position, assign 1. Next step, step 5, we can run those functions to generate the mean and standard deviation, and the mean and standard error and the standard deviation. Very good. The analysis is now done. Let's generate the result to 2 standard deviations, 2 decimal places. For earning power, we have an average of 296.13 and a standard error of 4.20. And in terms of standard deviation, here we have 141.27. And that is all you need to report. You can see our references here. You can see the author affiliations, myself and Kaidar. And that brings us to the end of this video presentation. I hope it was useful. If you have any comments or ideas, please enter them into the comments below. Thank you so much.